Hello and welcome back. This is Mr. Keeney, and today we will be talking about areas of circles. And just to warn you, I left my good stylus at home, so I am on the struggle right now. Area of a circle. So, to find the area of a circle, we're going to use an equation that you've probably seen for a while, which is pi r squared. R standing for this r right here, being the radius. So, this is probably not new. It's probably something that you're used to and that you've used for a while, but in order to find the area, we need the radius. So that's probably not the new thing. Maybe what's new to you is area of a sector. And sector, or the area of a sector, is the area between two radii, or radiuses, if you want to say. And as you can see here, it looks like a pizza slice. So, if I want to find the area of that shaded figure, what I'm going to use is this proportion. And so, to understand this proportion, let's break it down a little bit. So here is pi r squared. What that means is, well, that's the area of a circle. That's the total circle. And here on this bottom is 360, the total degree measure. Now, how we're going to find the area of the sector is pretty simple. We're just going to find a portion of the entire area. So area of the sector, or the slice, we set up equal to degree of the arc, because again, the sector here has this arc AB, which is just a portion of the entire 360. So we're going from part to whole equals part to whole for our proportion. Now let's get straight to some examples. Find the area of the circle. Pretty straightforward, so we're going to use our area formula. Area equals pi radius squared. And we can see over here that our radius is 7, so area equals pi times 7 squared. And so our area of this circle is 49 pi centimeters squared. And that is our terms of pi answer. Now, if I want to get my decimal answer, I just take 49 pi and I put that into a calculator, which I have one over here next to me. You can't see it on the screen. And 49 pi, or 49 times pi, is 153.93 centimeters squared. And notice that I'm back to centimeters squared because this is area, that we're in the second dimension. It's 2D space now, different than when we were doing circumference, which was just measuring a distance. Next example, find the area of the circle. This right here, this is the diameter. If the diameter is 13, then our radius is 6.5. Or we can say radius is 13 over 2, 13 halves. So we're still going to use our area equals pi r squared. I'm going to try to keep it in terms of pi, so I'll say equals pi times 13 over 2 squared. So if I want to square, which I'm going to use my calculator, but really what you're doing with that is that when you take it to the second power, and you can check this with your calculator too, is you're just squaring, and let's see if I can show you here with our little tool. We're just squaring 13 and we're going to square 2. So the area equals pi times 13 squared is 169, 2 squared is 4. So for our terms of pi, our area is 169 pi over 4. Wow, my voice cracked. Inches squared. Now if I want to get the decimal for my decimal people, you just take that and you put it into the calculator, and what you should get is 132.73 inches squared. So a lot of this is very similar to finding circumference. It's just using a different formula. And I say circumference because that was our last lesson. Next example, so we got something kind of new. We're going to find the area of the shaded parts, which is the black parts. So if I want to find the area, what I'm really going to do is I'm going to find two different areas here. I'm going to find the area of the, we'll say, rectangle, and I'm going to find the area of the circle. And if I find those two, then I can take the difference, because if I were to find the area of the entire rectangle, so I'm finding everything, and I'm going to act like this is coloring in, and then I subtract away the circle, I'm left with a shaded area. So I just need to find the area of both these things, and then I can subtract. So the area of the, looks like, well, it would be a square here, because this would be 8 inches as well, because it's diameter. So I would just do 8 times 8 and get 64. So that is the area of the rectangular square, I guess, or quadrilateral, whatever you want to say. And area of the circle is pi r squared, which is equal to pi times 4 squared, because remember our radius would have to be 4 inches if our diameter is 8, and so it would be 16 pi for our area. So the area of the shaded figure would be 64 minus 16 pi inches squared, which is our terms of pi answer. And now let's just take that and put it into a calculator. So 64 minus 16 pi, and we get 13. Area is 13.73 inches squared. So the big thing here was, again, having that relationship. Well, if I find the area of the entire square, and then, here, let me fill all that in, or close enough, but then I find the area of the circle. What am I going to do with the area of that circle? I'm going to subtract it, and I'm left with just those black edges right there, which is exactly what we did in our work here, and then we subtracted it down there. So, moving on. Area of a circle is 58 square inches. Find the diameter. So a little bit different, but I am going to still use my area formula, except for this time they give me that the area is the given information, so I'm going to plug in 58 for the area, and that's equal to pi r squared. I'm going to try to find the diameter, but in order to find the diameter, all I have to do, or not but, so what I'm going to do is I'm going to find the radius, and then I'm going to use the radius to get the diameter. So, first thing is divide by pi, so the pi's will cancel out. So I have radius equals 58 divided by pi, and then I'm going to square root both sides. So my radius is, and I'm not even going to mess around with terms of pi on this one. I'm going to go straight decimal, and my radius is 4.30 about. So we're going to say the radius is 4.30, but again I'm trying to find the diameter, so to get the diameter I just double that and I would get 8.60, and this is in inches. So diameter, all I had to do was use my given information, which was in this case was the area of the circle. I plugged that in for my area, and then I solved for r. In order to get r, I just multiplied by 2. Alright, now the stuff I really want to talk about, which is finding the area of a sector. And again, a sector is this just like little slice over here of the circle. And what we do is really similar to how we find arc length, is we're going to use this proportion. So we're going to fill in what we know, and really this will be 360 always, and up here is going to be x because that's what I'm looking for. Now finding the area, well, my radius is 10 squared is 100, so my area is 100 pi. Degree of my arc, they give it to me, it's 60 degrees, and there we go. What I first like to do is I like to take this fraction here and reduce it, or ratio and reduce it. So I'm going to leave x over 100 pi how it is, and 360, or 60 over 360 reduces to 1 over 6. Now I'm going to cross multiply. I'm going to change colors too. I'm going to go up here. X times 6 is 6x, and 100 pi times 1 is 100 pi. Divide both sides by 6. And so I got x, my area is, if I do terms of pi, I'm just going to reduce 100 over 6 to get 50 over 3, and here's my pi, and we are in inches, so inches squared. Or if I want the decimal version, I can do calculator work to get about 52.36 inches squared. So the key parts of this one is just making sure you plug in your given information. I will always have 360 here. This will be what I'm looking for, the area. And the two things you really need are your area, which I find that by using the radius. And I need my degree arc. In this case, they just gave it to me over here. So I just plug that in, and then it's just solving proportions from there, which we've done for a while, even before this class. Let's try another one. So we are going to set this up by ourselves. So to set up our proportion, two ratios equal to each other, I'm going to have my area, what I'm looking for up there, area of the sector, and over here a total circle will have 360 degrees. I'm going to rewrite that, 360 degrees. Now, area of the circle, radius is 8, so 8 squared is 64. So my area is 64 pi, because 8 squared is 64. And then my degree arc, do not use this because I need this arc down here. But I can just do 250, I can do 360 minus 250, because again a total circle is 360, and I get 110. So this is 110 degrees, and I can put that up here. I'm going to reduce that ratio, so x over 64 pi equals 110 over 360 will reduce to 11 over 36. Not too much help, but we'll take all the help we can get. Cross multiply, 36x equals, and then 64 times 11, my goodness, 704 pi. Divide both sides by 36. These cancel out. And for my terms of pi, reducing that, I get 176 pi over 9. And what I'm doing there is I'm just taking this and putting that in simplest form, in reduced form. And then to get a decimal, I'm taking what I got for terms of pi and putting it into a calculator. So I'll take 176 pi over divided by 9 in a calculator, and when you do that, you get 61.44 inches squared. And I forgot my units up here, inches squared. So that is about it. As you can see, a lot of these end up being the same way, or the same kind of problem. For this one, let's go ahead and set up what we know. We always know that we're going to be looking for our area up there, and our total degree measure is 360. For our area of the circle, they gave us a radius of 5. So I need to plug in 5 squared is 25, so 25 pi. That's just the area of the total circle. And if this is 78, then this arc is 78 degrees. But I'm looking for this because I'm trying to find the area of the sector the shaded one. So I do 360 minus 78, and when I do this, I'm not even going to use a calculator just to be sure. I get 282. And that is the degree measure of my arc. I'm going to reduce this fraction over here, and it helps me out a little bit. So x over 25 pi equals, when I reduce 282 over 36, that gets me 47 over 60. And how I'm doing this so fast is I'm using my calculator, my TI-84, and I'm putting 282 divided by 360, and then I'm just hitting math, enter, enter. Excuse me. From here, cross multiply. 60x equals 25 times 47. 25 times 47 is 1,175. Don't forget your pi. Divide both sides by 60 now. And what I get from here, so the area of my sector, I'm going to reduce 1,175 over 60, when I reduce that, I get 235 over 12, and again I'm reducing that using my calculator. And remember your pi, and this will be feet squared. To get the terms of pi, I just put this in a calculator, and my area is 61.52 feet squared. All right, looks like we're coming up I think we got one or two more. Oh, and I think that was it actually. Make sure I'm going through. Yep, I did all of them. So this is actually kind of quick one. And if you've done circumference before, then finding the area of a sector, and it's very similar to arc length. Instead of using circumference, we're using we're going to find the area of a sector. We're going to use the area of a circle. So this has been Mr. Keeney, and really the stylus was an issue. I was really worried. More is my voice. I think I'm coming down with something, but anyway, hopefully this helped you. If you're in my class, it helped you on your homework. Maybe you didn't need the help and you just want to stop on by. Either way, I hope you had a great day, and hopefully I learned you something today. So thank you for watching, and I'll see you guys next time.